Hello my dear students. Now let us discuss one more important short answer question, that is about the apparent weight of an object when it is placed in a lift. It is our regular experience that whenever we use a lift, if you move upwards or move downwards, we will feel either our weight is somewhat increased or decreased. So what is the main cause behind this? And when we feel that weight is increased or when we feel that the weight is decreased, we are going to discuss today. See, this is a lift cable, and assume you are standing on a weighing machine. Assume the lift is at rest in the initial condition. When the lift is at rest, if your mass is m, what are the forces acting on you? Or what are the forces acting on the weighing machine? Let us see now. On the weighing machine, weight of the person mg acts in the downward direction, and hence the weighing machine gives a normal reaction in the upward direction, that is n. As the lift is at rest, as the system is in equilibrium, the sum of upward forces is equal to the sum of downward forces, and hence n is equal to mg. This is the case when the lift is at rest. Now imagine the lift is moving upwards with some acceleration a. As the lift is moving upwards with an acceleration a, then do you think that the normal reaction is same as before? I don't know. Maybe yes or no. Let us see. Assume that is not nu. U stands for upwards. So when the lift is moving in the upward direction, or you can say n1, whatever. So in this case, what is the net force? What is the net force acting on the person? See here, nu is acting in the upward direction, mg is acting in the downward direction, but still he is moving upwards with an acceleration a. That's why net force is equal to m into a. As he is moving in the upward direction, the upward force must be greater. That's why nu minus mg. Mg is moving in the downward direction, nu is acting in the upward direction. Hence nu minus mg. That implies the normal reaction when the lift is moving in the upward direction is equal to m into a plus m into g, which can be written as m into g plus a. So this is the normal reaction, or this is the apparent weight of the person when he is moving in the upward direction. As the ma is added to mg, his weight seems to be increased by ma. Here the apparent weight increases. If the acceleration of the lift is higher, the normal reaction also will be higher. Now let us see when the lift is moving in the downward direction with an acceleration a. Now imagine the lift is moving in the downward direction with an acceleration a, then the net force will be in the downward direction. The net force is equal to m into a only. Now what are the forces acting on the weighing machine in person? One is mg is acting in the downward direction, normal reaction acts in the upward direction. As a whole, the system is moving in the downward direction. That's why it seems to be the net force, it seems to be the downward force is higher than the upward force. That's why the downward force mg is greater than n, say d. That's why resultant force is downward force minus upward force. That's why is mg minus n downward direction. That implies normal reaction when the lift is moving in the downward direction is equal to m into g minus m into a. So this ma portion is subtracted from the actual weight. That's why he feels that his weight is decreased. So when the lift is moving in the downward direction with an acceleration a, he feels that his weight is reduced by ma. So it can also be written as m into g minus a. It has several other applications. We will see them in the JEE Mains course, and we will let us solve some problems in JEE Mains course. Okay, see you all.